Hello and welcome to AI Frontiers. Today we're exploring the landscape of machine learning through a unique lens, a collection of research papers released on a single day, May 22, 2025. These papers are cataloged under Computer Science, Learning on the Archive preprint server. This provides a snapshot of the field's current priorities. Our title for this episode is Machine Learning, a Frontier of Innovation, with the subtitle, Synthesizing 105 Papers, 2025-05-22 to 2025-05-22. We will be exploring the latest advancements, unveiling key trends and breakthroughs, analyzing research from a single day, and discovering future directions in AI development. Let's outline our journey through today's exploration. We'll begin by examining the current state of machine learning research. Next, we'll identify core themes, including efficiency, robustness, and explainability. Following that, we will highlight key findings and methodologies. This will lead us to spotlighting several seminal papers and examining their contributions. Finally, we will be envisioning future research directions. Computer science learning, often abbreviated as cs.LG, represents a dynamic and rapidly evolving area within artificial intelligence. It is fundamentally concerned with the development of algorithms that enable computers to learn from data without being explicitly programmed. This learning encompasses a wide range of tasks, from recognizing patterns in images and text to making predictions about future events and controlling complex systems. The significance of machine learning stems from its ability to automate tasks, extract insights from vast amounts of data, and create intelligent systems that can adapt and improve over time. These capabilities are transforming industries like healthcare, finance, transportation, and entertainment. Analyzing this collection of papers, several key themes emerge. One strong emphasis is on improving the efficiency and scalability of machine learning models, particularly large language models, or LLMs. As these models grow in size and complexity, it becomes increasingly important to develop methods that can reduce their computational costs and memory requirements. One paper explores efficient training of neural networks with adaptive sparsity, focusing on techniques to identify and prune unimportant connections in a neural network to reduce its size and improve its performance. Let's examine the technical concept of sparsity in the context of neural networks. Sparsity refers to reducing the number of non-zero elements within a model's parameters. This improves efficiency by decreasing computational demands during both training and inference. Sparsity is achieved through techniques such as pruning connections, effectively removing less important weights from the network. Sparsity also allows deployment on resource-constrained devices, as smaller, sparser models require less memory and processing power. Another prominent research theme is enhancing the robustness and generalization ability of machine learning models. Real-world data is often noisy, incomplete, and subject to change over time. Researchers are working to develop models that can perform reliably even when faced with these challenges. An influential approach is domain adaptation, where the goal is to adapt a model trained on one dataset to perform well on a different but related dataset. For instance, one paper introduces a novel domain adaptation technique for image classification, allowing models trained on synthetic images to perform well on real-world images. Another key research theme is explainable artificial intelligence, or XAI. As machine learning models are increasingly used in high-stakes decision-making, it's crucial to understand how they arrive at their predictions. XAI methods aim to make models more transparent and interpretable, allowing users to understand why a model made a particular decision. One approach involves identifying the most important features used by the model. Explainable AI is essential for high-stakes decision-making processes, ensuring accountability and trust in AI systems. Several results presented in these papers are particularly noteworthy. One standout result is the development of a new algorithm for training neural networks with adaptive sparsity. This algorithm automatically identifies and prunes unimportant connections in a neural network during training, leading to significant reductions in model size and improvements in performance without sacrificing accuracy. Another significant result is the introduction of a novel domain adaptation technique for image classification. This technique allows models trained on synthetic images to perform well on real-world images, overcoming a major challenge in applying machine learning to computer vision. Also, a new XI-A technique identifies the most important features used by a machine learning model to predict the risk of hospital readmission. Several methodologies are commonly employed in these papers. Deep learning is, of course, a dominant methodology. This involves training artificial neural networks with multiple layers to learn complex patterns from data. Reinforcement learning is another significant approach. It enables agents to learn optimal strategies by interacting with an environment and receiving feedback in the form of rewards or penalties. Bayesian optimization is also used. It is a technique for optimizing black box functions, where the function evaluation is expensive or time-consuming. Ensemble methods are also used, where multiple models are combined to improve overall performance. Let's delve deeper into the technical concept of reinforcement learning. Reinforcement learning involves an agent learning through interaction with an environment. Agents receive rewards or penalties for their actions, which guides the learning process. This enables solving complex decision-making problems in various domains. Reinforcement learning finds applications in robotics, game playing, and control systems, where agents need to learn optimal strategies through trial and error. Let's now examine some seminal papers in more detail. First, the paper by Li et al. 2025 is titled Robust Learning with Noisy Labels via Meta-WeightNet. The objective of this research is to address noisy labels in training data. The method involves Meta-WeightNet, which learns to weight training examples. Results showed that this approach outperformed existing methods, achieving state-of-the-art. The significance lies in improving accuracy of models trained on real-world data, which often contains noisy labels. Next, we turn to the paper by Park et al. 2025, titled Efficient, Deep Reinforcement Learning via Demonstrations and Hindsight Experience Replay. The objective of this research is to improve the efficiency of deep reinforcement learning. The method involves combining demonstrations and hindsight experience replay. Results showed significantly improved learning efficiency. The significance of this work is that it makes deep reinforcement learning more practical for real-world applications, where data is often limited and expensive to obtain. Finally, let's analyze the paper by Wang et al. 2025, titled Explainable AI for Time Series Classification via Attention-Based Convolutional Neural Networks. The objective of this paper is to develop an explainable AI method for time series data. The method uses attention-based CNNs to identify important timestamps. Results showed state-of-the-art performance with interpretable explanations. The significance of this work is that it improves trustworthiness of machine learning models by providing insights into their decision-making processes. Looking ahead, future research is likely to focus on several key areas. Developing more efficient and sustainable training methods is crucial for reducing the environmental impact of large models. Improving the generalization ability of machine learning models will enable them to perform well in diverse and unseen environments. Exploring new applications in diverse fields such as healthcare, energy, and agriculture will unlock the full potential of AI. Addressing ethical and societal implications, such as bias and fairness, will ensure that AI is used responsibly and benefits all of humanity. It's important to acknowledge that this synthesis was created using AI tools. A large language model was used for content generation. TTS synthesis was done using DeepGram. Image generation was done using OpenAI. Content reviewed by human expert. However, oversights are possible. It's always a good idea to verify the facts and check the latest research. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.